Hey guys, welcome back to study vlog number 10. Unfortunately, I have some technical difficulties, so today this video will be on a Google document. Okay? For today, as we can see here, we will learn about chemical bonding. There are two types of chemical bonding that we learn in Sec 3 combined chemistry. The first one is ionic bonding, and the second one is covalent bonding. These two are highly likely to be tested during your WA2 or your test. So let's start with ionic bonding. First of all, ionic bonding contains ionic bonds, which are formed by the transfer of electrons from metal to non-metal. Oops, bonds formed by transfer of electrons from metal to non-metal. Secondly, this means that metals lose electrons to form cations. Okay, metals lose electrons to form cations. These are positively charged ions because um, because when an element has an equal number of electrons and protons, like we learned in Sec 2, and once you lose an electron, there will be more protons than electrons, which is why you become more positive. So that's why we call them cations, positively charged ions. Third, this goes to non-metals as well. Instead of losing, they gain electrons to form anions. I don't know, sorry for my mistake if I pronounced it wrong, but these are negatively charged ions. It's basically like I said, you have an equal number of protons and electrons, but if you take one more electron, the compound will get more negative charge, which is why we call them anions. I yeah, sorry if I mispronounced it. Okay, fourthly, these ionic compounds will have a structure of a giant lattice. Like yeah, giant, giants. Like this is kind of like crystallized-ish. So yeah, and obviously for ionic bonding and covalent bonding, they each have their own physical properties. Okay, for example, for ionic bondings, they are soluble in water, insoluble in organic solvents, which is like vinegar, oil, and all that. Basically, the opposite of water. Yeah, and they are able to conduct electricity in molten and aqueous state, but not in solid state. Okay. For those of you who do not know what is molten and aqueous, it's basically molten is basically when a solid is melting, and the aqueous state is basically when a solid is becoming a liquid. Yeah, so they both kind of mean the same thing, which means that ionic compounds are able to conduct electricity in liquid state. Oh no, oops, in liquid state. Okay, and last but not least, they also have high melting and boiling point. Okay, before I go on to explain about uh, how they are able to conduct electricity and molten and aqueous state, but not in solid state, and how it has the ability, it has a high melting and boiling point. Let's go to covalent bonding. Okay, so covalent bonding is formed between non-metals and non-metals. Like over here, we can see that it is from metal to non-metal, but over here it is non-metals and non-metals, which for extra information, these are part of group 14 to 17 in the periodic table. Secondly, covalent bonds contain covalent bonds. Just like over here in the ionic bonding, they contain ionic bonds. Here they contain covalent bonds, the which is formed by sharing electrons between non-metals. I'll go through this later, so or maybe in another video. Number three, its structure. Oops, structure is small, simple molecules instead of a giant lattice structure like ionic bonding has. Covalent bonding only has small, simple molecules. Okay. Fourth, like I said earlier, covalent bonding also has its own physical properties. For example, they are insoluble in water, they are soluble in organic solvents, and they do not conduct electricity in any state, and it also has a low melting and boiling point. Okay, so before I move on, let me just show you the differences between these two. So over here, we read that this ionic bonds is between metal and non-metals, but for covalent bonding, it's between non-metals and non-metals. Ionic bonds are formed by transfer of electrons, which is when the metal gives its extra electrons to the non-metals. But over here, in covalent bonds, they are formed by sharing electrons. So yeah. In here, we say metals lose, non-metals gain. This one is non-metals both share a number of electrons. Then let's say the structure of ionic bonding is a giant lattice structure, while a covalent bonding is a small, simple molecules. You see that? I have highlighted the difference, and for physical property, soluble and insoluble in water and organic, but it's the opposite for covalent. Well, for the conduct electricity part, they are both the same when both of them are in the solid state. But for this one, it's in liquid state that is able to conduct electricity, and this is not being able to conduct electricity in any state. Then high melting and boiling point. Here is also high melting and boiling point. Okay, so let me explain why ionic compounds are able to let me explain why ionic compounds are able to conduct electricity in molten and aqueous state. So firstly, we know in the liquid state, particles tend to move around freely while still in contact with each other. So over here, the wait, over here, over here, mobile ions are free to move around while carrying electric charge in the aqueous and molten state. Like I said, the liquid particles are able to move freely but still in contact with each other. So they move around, they carry electric charge. This electric charge are your protons and neutrons. And that is why it can conduct electricity in the liquid state. But in the solid state, ions are held in fixed positions in the giant lattice structure and are not mobile. Basically, we learned in Sec 2 that in the solid state, particles are held in fixed positions. So the forces of attractions are very strong, are very weak, sorry. So it the ions or the particles in this case, the particles or the ions in this case are held in fixed position, which is why they are not mobile to move around while carrying the electric charge. So they can't conduct electricity in the solid state. There are some very important keywords here, such as mobile ions. If you don't write the word mobile, apparently they will deduct a mark. You must say it's either you write mobile ions or free to move around. Then you must also write carrying electric charge. If you want to talk about the aqueous and molten state. But if you're talking about the solid state, you need to say that it's held in fixed positions. And so because of that, they are not mobile. This part is not really that, uh, let's say, important, but it is good to remember. Now let's go to the high melting and boiling point. Why does it need such? Why does it need a high melting and boiling point? Well, for ionic bonding, a lot of energy is needed to overcome strong electrostatic forces of attraction between oppositely charged ions. Okay, a lot of energy is needed is as important. Overcome strong electrostatic forces of attraction is also important, and you must write oppositely charged ions. For covalent bonding in the physical properties, we learn that it does not conduct electricity in any state. And the reason being is because there are no mobile ions or electrons to conduct electricity in any state. Like we know that this uh, covalent compounds share electrons. They don't simply give each other like exchange electrons, which is why there are no mobile ions or electrons to conduct electricity in any state. Okay, next is why it has a low melting and boiling point. This is because unlike ionic bonding, little amounts of energy are required to overcome the weak intermolecular forces of attraction between the molecules. Okay? I hope this helps whoever out there understand chemical bonding even more. And next video will be on how to draw the ionic bonds and covalent bonds. and like simple elements as well. We will also be learning some chemical formulas to memorize for the exam. That's all for study vlog number 10. Bye!